When the modulus of x is 3, we get two possible answers for x, 3 or minus 3. So it's the absolute value and it basically just removes the negative. So then when x equals 3, the modulus of 2x minus 1 is going to be 6 minus 1, the modulus of 5, which is simply 5. So that's one possible value. And then when x is minus 3, we're going to get minus 6 minus 1 modulus of minus 7, which is then 7. On to part B. We'll ask for the set of values for which this is true. Now, my approach for this is always to draw a sketch. I think it's just a good shout. Okay, so first of all, modulus of 2x minus 1. I'm going to find what we call the critical point. That's when it's going to equal 0 and basically, when the modulus is going to come into effect. So it's going to be when 2x minus 1 is 0, hence at a half. So I know it's going to cross there. Then it's going to come down, it's going to sort of bounce off. So I can just draw it a little bit like this. It doesn't take too long. And it's all going to come together in a minute. So it then goes through the axis at 1 when x is 0. Right, next up then I've got to draw y equals x plus 1. That's going to go through 1 here. It's going to have a shallower gradient. So it's going to look maybe a little bit like this. Not perfectly to scale. So I can see now I might need to extend this. Maybe make it look like that. There we go. And I can see the intersection points. So where is the modulus of 2x minus 1 greater than x plus 1? It's going to be here and here. So I just need to find the intersection regions. Well, I've actually already found one of them, so I just have to find the other one. So when x is greater than a half, I mean, I can just ignore the inequality for the time being and find out where they cross. So when x is greater than a half, the modulus isn't going to be doing anything. I'm actually going to be finding, this region here. So I'm going to get that 2x minus 1 is equal to x plus 1, and therefore x is equal to 2. And then let me just show you, when we go with x is less than a half, I'm going to get the minus 2x minus 1, which becomes minus 2x plus 1 equals x plus 1. And that leads to x being 0, as we saw here. So overall, we've got x less than 0 or x greater than 2. And giving our answer in set notation, this becomes the set of x such that x is less than 0 unioned with the set of x such that x is greater than 2. Just realized that, sorry, that should have been an equal sign there as well when it's greater or equal to a half. Then I find like the whole kind of range, but it didn't really matter at the end of the day. A couple of points then. So I chose to solve it when it was equal, but you can actually go straight for the inequality. Sometimes it's just a little bit more technical though. So it would have actually been 2x minus 1 greater than x plus 1, than x greater than 2. So it would have come straight out. And then for x less than a half, minus 2x plus 1 is, greater than. Just if you got the graph, it just feels like a little bit easier to solve the equation than the inequality. That's all I'm trying to get across here. It would go to x is less than 0. And then it would work out from here. You just have to check that it is satisfying like this condition and this condition. So sometimes you have to alter your inequality answer. But in this case, there isn't actually any effect. So we would just get these as our answer. One final method. I don't like this method, but I just want to talk about it. So sometimes people solve these by squaring both sides. Again, it's going to involve treating it as an equation because you cannot square when you have an inequality because potentially the sign can change round. So that will become 2x minus 1 squared equals x plus 1 squared. 4x squared minus 4x plus 1 equals x squared plus 2x plus 1. The 1's cancel. Going to get 3x squared minus 6x equals 0. And that way we get x equals 0 or 2. At this point, you just have to maybe try different values each side and see where the region is. It just I mean, maybe there are other ways to do it. I just never use this method anymore, so forgive me if I'm not quite up to speed on it. But it just feels clunky in my opinion. So my suggestion actually is to do it the way I did it. Get a graph down, forget the inequality for the time being. We can see the region, just find the points of intersection and then construct the region from there.